Dear students, this is the continuation of the previous video, a continuation of this problem. Okay. Now, actually, we have to prove that S3, composite is a symmetric group. Okay. Now, what I have explained here, see, if you take sigma 2 and sigma 3, do composition, you will get sigma 6. Okay. Then how to write the cycle form into the permutation? I explained here. Then similarly you write the remaining, because sigma 1, sigma 2, sigma 3 I wrote here for you. Then what you have to write? Sigma 4, how to write in the permutation form. Sigma 5, how to write in the permutation form. Sigma 6 also. Okay. Then if you do composition between sigma 2 and sigma 3, what you are getting? Sigma 6. This also I explained. Okay, similarly you do for the remaining, you fill this table. Okay, this is the way how you fill this table. Okay, use the composition, then you fill this table. Okay, now you see here we are going to prove this symmetric group. Okay, forms a group, symmetric group. Okay, so now how to do that? Okay, how many properties we have for group? We have 4 properties: closed, associative, then identity, finally inverse. For group I am asking 4 properties: closed, associative, identity, inverse. Okay, 4 properties. Okay, closed means what? You take, already we have solved and proved, discussed so many questions on closed. Okay, see, closed means you take any 2 elements, then you apply your binary operation, then finally what you are getting, the result, an element that is also in your set. Okay, that is closed. Okay, which means you see here, after completing this table, you see here you take any 2 elements, which means you take this and this, you do the binary operation composition, then what element you are getting, this element is also in your set. What is your set? S3 is your set. See here what you are writing, your elements. Okay, what you have in S3. Here what you are writing, your elements, what you have in S3. So you take any 2 elements, you do the binary operation, then finally what you are getting here, see what you are getting here, all these elements also in your set, which means this is clearly closed. Okay, what is associative? Associative means you take any 3 elements. See, you see here you take any 3 elements. See, you take sigma 2, sigma 3 and this sigma 6. You take any 3 elements, you do the composition, finally what you are getting, both side equal. Okay, that is associative. Clearly associative is also true. What is the identity? Identity means what? Okay, identity means what? See, you see here, you take this identity element, you operate any element with identity, again you will get the same element, that is identity property. Clearly we are getting here. Okay, so that's why I told here, you see, like this, how I did sigma 2 composite sigma 3, you do all possibilities, you see, you do all compositions, then you fill the table, then you are getting, you see, this is the identity element, you see, this is the identity element, you see, this identity element, you do binary operation, that composition with any of these element, you are getting the same element. You see here, this is the identity element, you do binary operation with any of these elements, again you are getting the same element, which means identity property is true. Okay, now what is the last one? Inverse property. What is the inverse property? Say you mark the identity element, that's what I did. See here, this is the identity element I. Okay, because see here, sigma 1 is equal to empty means this is the identity element, that's what I am writing here, I. Okay, see, that's what I am writing here, I is nothing but sigma 1, that's equal to, see here is assume itself 1 1 2 2 3 3. Okay, that's the identity element. Okay, now you see here, this is the identity element. Okay, now you see, mark this identity element, then you go, see, in this row you see this element, and you see this here, this element, which means 1 2 3 is the inverse of 1 3 2. In another way we can say that 1 3 2, inverse of 1 3 2 is 1 2 3. Okay, you say, that is what here mentioned. listed. See, inverse of the identity element is I, then inverse of 1 2 is 1 2, inverse of 1 3 is 1 3. How they're writing? You see here, for 1 2, here you see identity element, you go above, see 1 2. So inverse of 1 2 is 1 2. See, inverse of I is I, because here you see here this, see here 2 3, see identity, go above 2 3. So inverse of 2 3 is 2 3. You see this is the identity. So 1 3, inverse of 1 3 is, see, 1 3. Okay, similarly you see here, similarly this is identity. Now you see 1 3 2, see here identity I have, so go 1 2 3. Okay, so inverse of 1 3 2 is 1 2 3. So inverse of 1 2 3 is here 1 3 2. Okay, that is what here listed. Okay, so which means what? All four properties valid: closed, associative, identity, inverse, four valid. So that I can say that this S3 comma composition forms a group. This is the conclusion. Okay, that's it. Thank you.